Okay, the following table shows the daily number of watches sold at a shop and the amount of money made from the sales. Okay, so there's 25 watches sold, and this was amount, and so on, right? Part A says, does the data in the table appear in a linear relationship? Linear relationship means the slope, if you're to plot this, a slope, is a slope constant. A line graph, right? If you take a line, right, no matter what 2 points you take, the slope will be constant. So it's called a linear relationship. In a curve, right? Let's say if you have a curve like this, right? Depending on where you take the 2 points to find the slope, we get different slope values. So this is not a linear relationship. This is. Now, to determine if it's a linear relationship or not, the first thing we need to do is to list this from least to greatest. Okay, so let's put 12 first up here. 12. Let me just extend the table here. Okay, so 12, 210. Okay, the next big number is 17, 297.5. Okay, and the next one is 20, 350.00. The next one after 20 is 24, and then 25. Okay, so let's find the slope here. The difference between 297.5 and 210 is 87.5, and the difference in the number of watches here is 5. Okay, so that gives you 17.5. So this is 17.5. So let's take these two values. Okay, so 350 subtract 297, that gives you 52.5, and divide by 3 again. You can see that it's not going to be the same, right? So it's actually no, 5 and 3 maybe. Let me just calculate that. You 17.5. Okay, so let's do the next two pairs. Let me put it here. 420 subtract 350 is 70. Divide by 4 is 17.5. So it's starting to look very convincingly that this is a linear relationship, meaning the proportion which you sell, the increased number of watches you sell, the amount of money that it goes up is consistent. Okay, lastly, this is going to be 17.5 divided by 1 is 17.5. So it is linear. Okay, so is it a linear relationship? The answer is yes. So graph the data. So if you plot this, right, it's going to form a straight line. So let me just plot it approximately. Let's say this is 12, right? 12, 17, 20, right? And then there's 24 and there's 25. Okay, it's not the same scale. So let's just say it goes up here somewhere, and then we're starting at 210. Right, and then 297.5, 350. Okay, and then 420, and then 437. Okay, so when you plot these, okay, I'm not plotting it accurate obviously here. But when you plot these, it has to form a straight line, right? Because slope is consistently the same value. Okay, so it will look like that. So what is the average rate of change from 20 to 25? It's consistent. The average rate of change is always 17.5. Okay, always 17.5. What is the cost of one watch, and how does its cost relate to the graph? For this, you first need to find the equation of this line. Okay, equation of line requires a point. So I'm going to take hopefully the nicest point, this looks pretty nice, 12 and 210. So 12 and 210. And the slope, the rate of change is 17.5. So with that, I can say my equation is y minus 210. Right, so y minus the y coordinate. Slope 17.5 times by x minus x coordinate. This is called a point slope form. In here, you just have to plug in x is equal to 1 to find out the cost. So y is the cost, x is the number of watches. Okay, so 17.5, x replace it with 1. So 17.5 times by minus 11. Finally, if you just add both sides by 210, okay, then we get a 17.5. Okay, 17.5. So it's basically almost near touching the y-axis, right? You know, the y-intercept is approximately 17.5. It's gonna be a little bit lower than that, obviously. So at 17.5, when x is equal to 1. Okay, when the number of watches is equal to 1. So it says, what is the cost of one watch, which is $17.5? How does cost relate to the graph? The average rate of change was 17.5. Well, this makes sense. Each watch costs 17.5, right? So every watch you sell, right? So every watch you sell, it'll generate $17.5 more dollars, because that's how much one watch costs. That makes a lot of sense, right?